Hello. Very nice to see you all here. I'll try to be a bit quicker, maybe, so we'll have some break as well. So yeah, personalization, literally for everyone. I'm Ali, as he was mentioning. I work on social robotics and language development. So I put children in front of social robots and I see how it affects their language development. But I especially focus on children with ADHD and ASD, autism spectrum disorder. But this is not what I'm going to talk about today. It's another project which vaguely connects to this point. So very simple outline. First, I'm gonna describe what do I mean by personalization, and then what is my approach to it. What am I doing with it? Um, so yeah, human history is entangled with inventions. As long as we know, we started creating things to simplify life for ourselves. But I see them in two different classes of inventions, maybe. So one class is the ones like wheel, which really doesn't matter. It doesn't matter to you. You just use it. It is connected to something else. So it doesn't matter who you are. Regardless of who you are, you can just use the wheel and without any problems. But then there are some other inventions like these staircases. Like it, probably most of us can climb the stairs, but if we are an elderly or you have motor dysfunctions, it might be a bit harder for you than if you're carrying your child, or if you're disabled. I mean, you're on a wheelchair. It's practically impossible. What we started doing during the history was to make some mitigations, like making elevator, escalator, or ramps. But then now let's consider these help some of these major minorities, or like big minorities. But then imagine someone on a wheelchair who has claustrophobia as well, like that they cannot go on the elevator. What do they do when they get to a building? Like, so these are cases that are not so few actually. Like, now let's take a look at a more language case. Imagine a user watching a tutorial video on YouTube. You just watch and listen. But if you're deaf, then you turn on the subtitles. If you're deaf and you have dyslexia, then probably the magical button we have imagined now, that the start sign language synthesizer. So an animation comes up and synthesizes that for you. But then imagine you have also autism. I mean, the combinations could happen, and you're bothered with too much visual stimuli. So what do you do? Like, how do you keep watching that? I mean, you want to watch. So there's no option. So there are, this is what I call, and that introduces something that I call subjectivity problem. And so you have different technologies, mostly compromised for most of the people, for majority. But then there are lots of people and lots of different combination of situations and resources and opportunities that people cannot access lots of these technologies that we made. So their lives are not simplified as ours is. Now let's get to more of language technology examples that I wanted to show you. So most of the people here talk about translation, so I don't focus on it too much. But then there's something very interesting. Is there anyone familiar with text simplification task? Could you raise your hand if you? No. Yeah, could you name one or two of the problems that are major problems in text simplification? Do you have anything in mind? Anyone?
The meaning of the text, basically. When you simplify, sometimes you will lose the information that you really want to transfer.
Mm-hmm. Yeah, please.
For example, in aphasia cases, they simplify the therapist when they talk to the patient. They simplify and try to ask them, what do you mean, or to change the structure of the sentence for them to understand what they are saying.
Of course. Anyone else has any points? So I think, do you have anything in mind?
No, I was just going to say, I mean, in general, selecting what is essential, like what's the part of the meaning that you need to get across.
Yeah, and I think this is the point, and also the other point. so when you say text simplification in computer science, you have, as one other person, I don't remember who was mentioning it in the morning, that there's this competition of, oh, now we outperformed the last year model. But then no one really thinks, okay, simplification for who? That's the first question you ask in the simplification, or tasks like that. And it's a drastically subjective task. You know, if you're simplifying for an aphagic, it's completely different task than if you're simplifying for someone with ADHD, for example. You need to just break down the sentences if you're simplifying for an ADHD, versus if you have just a language learner, you need to simplify the probably vocabulary. So it's hugely diverse. What they do now is either they don't mention at all for who they are simplifying, or it's very specific. And what's the problem with that is that we cannot start simplifying everything, like manually detect all these subcategories and say, okay, now I'm simplifying for aphagic people who are L2 language learners. Then you are developing a whole new system. And then for another category, a whole new system. So since these combinations are many, there are lots of combinations, so you cannot make new whole systems for them. So that's where, yeah. So how do we deal with this problem, and how do I approach it? Is that probably, as I was saying, like getting all these subcategories, well, that's probably impossible, because what I just mentioned, you cannot go manually over all of them and develop everything from the scratch. But perhaps not. I mean, is this something familiar to you, the personalized ads? We are pretty much advanced in this area. The point is that now your Google or whatever system you use, as iPhone or it's Apple systems or whoever's ecosystem you're using, Amazon, they have a very pretty good idea about you. I mean, as soon as you think about your dog, then the next ad you see on Facebook is the leash like setting. So we are pretty much advanced in that area. Why aren't we in things like language technologies? Well, that's probably because it's not financially justified for the big corporates, and that's where academia comes in. Okay. Yeah. So then it all happened when Matthias Lundin, a master's student at KTH, came up to me for supervision, and he was interested in conversational systems, and that's basically what we do at TMH, or my division at KTH. And I had this idea of personalization for such a long time. And what do I mean by personalization is that, okay, instead of making new technology for each of these subcategories of minorities, let's make a system that can detect all these differences and adapt to these differences. So you just make one system that can personalize to any user. So it doesn't matter, you don't make a whole new system for ADHD people, but you make a system that can detect what its user wants to be an ADHD or autism or any type of other requests or preferences, and then adapt to that way that they like, or it optimizes their performance. So we thought, okay, what to do about that? Is that I was working on language learning. I mainly work on language learning, so I thought, okay, let's take the state of the art of all these texts that we have around and have fun with them. So we came up with the idea to make a chatbot, personalized conversational agent. And we aimed to improve the grammatical and conversational skills in English as second language. So what we did, first we wanted to put it on a robot, which is called Forhat. But then there was this problem of language learners and automatic speech recognition. 9 minutes, okay. And the mismatch of the technology. So we said, okay, we keep it simple and we go on a chatbot. We use GPT-3, which is a language model. Does everyone know what it is? Or it's just basically a language model, very good one, but probably will be outperformed in the next 2 years. Then we used another system called Gramformer and another system, which is T5. I forgot to put all the references apparently, but I can send it to you later. So I'll just describe to you what the system does. It's very simple. First, the system has an introduction and it welcomes you and it sends an initial message. And then you reply to that message. Well, the first thing that it does, it goes and checks your grammar and the sentence structure if there's any mistake that in what you said. And the next very important stage is when the system decides what to do with that if you have any mistakes. So if you have any mistakes now, we detect the mistake, where is the mistake, what is the correct form of saying it, but we don't say anything to the user yet. So our system is supposed to decide on this stage, whereas should I give a correction now or shouldn't I give? Probably like if I make so many mistakes on a specific case, like let's say I use is instead of are, then probably it has to explain to me better versus when I just make one mistake, which we mostly do. I don't want to be interrupted all the time. So our system is supposed to decide when to give correction and what type of correction. So we have defined different types, which are, and we didn't define, we took it from the literature. So there's informative, which is just says, oh, you had a mistake in this word. And there is corrective, where it says, oh, the correct way of saying whatever you said is this. And there is combination of those two that says the problem was here, and the correct way of saying what you said is this. And there's elaborative, where it works out through the mistake with you, and it asks you like, there was a mistake in the question, where do you think it is? And well, basically also giving no correction. So that's also a type of correction in the system. Then it just produces the response. And here's an interesting thing happening, is that the user here decides very simple, good or bad. The user says, did I like the response or didn't I like? And it is about all the responses that the system gives. Now we get to the point where I will describe how we use it. But then I just show you the case, like how our system works. This is a welcome page. It describes the GDPR or how to work with this chatbot. It's very simple JavaScript. The artificial intelligence introduces himself. I'm Ben, artificial conversation partner. Today's topic is about human digestion system. What processes start when you put a piece of food in your mouth? So this is, as I mentioned, GPT-3, so it's open domain. You can just talk literally about anything. And that's the good part about these new technologies that enable us to do such things. It wasn't possible, I don't know, 2-3 years ago. Then I replied that I honestly don't have any clue about that topic. Can you tell me about it? And it says, well, digestion starts when you put food in your mouth. Very straightforward, but you can choose if it was good or bad. And that is what defines the next time when it wants to produce a sentence in reply to something similar to this, what to do now. Then my screenshot didn't capture that. I just said, what is digestion? And it says the digestive system is a group of organs in the human body that helps you break down food and extract nutrients from it. And I wanted to make a mistake, so I did a mistake. What is the process is happening? And it makes an informative correction, which is you made an error in the word is. And then I say, cool, so what is the process? What is these processes happening? And then it sees that I'm consistent in this problem, so it starts explaining a bit more. And then referring back to this original sentence, it replies to what we were talking about before. It is caught there. It doesn't make sense because we put a limit in the pilot, so it doesn't produce more than a specific amount of characters. So it has more to say, but we just cut it down. Then you just say anything. I mean, that noise is incorrect, but it knows that I'm just, I'm like joking or being cool with him. So he doesn't correct me there because it's going to be very annoying if you're just having a conversation and you say something like that and they correct you. And just to show that you can just talk about anything in between, it is like, are you alive? Do you have emotions? Yes, I have emotions. I don't know why. But aren't you merely a language model and servant of humans? Yes, I'm a language model. And then when I say, doesn't that make you sad then, to be servant and not having free will? And it says, oh, you should say, doesn't that make you sad then, to be a servant and not have free will? So it's having and not have. I don't know if this is correct correction. No, it doesn't make me sad. Best chat. And then after that, what we do, so these conversations go on each session 10 minutes. And then we show the user a form with like 10 to 20 sentences. We randomize the mistakes that they made. We put the same sentence like here, what is the process that's happening? And we ask them to correct if there is any error. So in this way, we measure how much these different types of corrections had effect. Like if an informative feedback is better for this user, or corrective is better, or the combination, or elaborative, in the learning outcome. So in the end, which ones did they remember better? And they can go on with this different sessions, and the system gets more accustomed to them, more adapted. The stage that we are in now is a crowdsource, so we are putting this online, and there we go. Crowdsource it with like hundreds of people. This is only a data collection stage where we just get these good or bads. With that, we train different neural nets. So now we want to understand which of these neural nets is better to remember the preferences of people, and we make a general base model neural net that decides on that correction types. After that, so the personalization hasn't happened yet here, and we will just compare it to the random system. So the baseline, we just now randomly produce those corrections. So now we don't decide, the system doesn't decide, it's just random. But then after that, we train a model. We put the baseline there. So the next step would be the next master student who's coming from Italy to KTH for her master thesis. It's going to be the personalization part, where we take that base model and now train it with each user's individual experience. So as I type, we use the continued learning methods that I'm not yet familiar much with, but that's what I'm going to explore more. These are new methods in machine learning, apparently, so you continue to update the model on the way for each user. And see how does that have effect. Does it improve the learning, or it doesn't improve the learning? So it's very vague area yet. So I want to explore that and see how this personalization might have effects. As you know, like in the systems, in current systems in language learning, like Duolingo, it might change the content based on your experience, but it doesn't change the method that it teaches you language. It's just certain methods which might not work with you. So if it doesn't work with you, you never can use Duolingo. Yeah. So it's not really inclusive. And these methods of personalization, I think if they worked, were advertisement pretty well, and they're making the whole wealth of the company with that. So why not personalization working for other technologies that we have, like language technologies? So it might become more inclusive for all the people. I'd like to thank European Union funding my PhD project, Marie Curie project, and Lisme for giving us the opportunity to come here, network with everyone. And yeah, thank you very much.